Hello, Proviso Math students. This is Mr. Appleman, and today I'm going to be talking to you about the Pythagorean theorem. Now, what the Pythagorean theorem is a method to be able to do something called indirect measurement. So in the real world, it's very difficult to measure things that are very large or very small, especially when we're talking about distances, like how far it is from one city to another. Now, there are more effective ways as we get further into the mathematics of things, but one method that is used for this is something called the Pythagorean theorem. What we're going to look at are the fundamentals of that today. We're going to start with the fundamentals of how to actually name the sides of the right triangle and where those locations are. So we'll start off with the three sides being known as leg A, leg B, and the third side is not actually known as a leg, but is actually referred to as the hypotenuse. Very strange word, but understand that this is coming from someone whose name is Pythagoras. So these words are going to seem a little odd to us. All right. The important thing in all of these is really identifying the hypotenuse. That's everything about these. If you can't do that, then this is a non-point. You can't do these things. The hypotenuse, similar to leg A being called A and leg B being called B, the hypotenuse is often referred to as side C. And I'll use those interchangeably, hypotenuse and C. When I look at this image and I'm trying to identify or label, I would recommend every time you're doing a problem like this, especially at the beginning, to label each side appropriately. The way you decide the labels is always start with the hypotenuse. And the way you decide the hypotenuse is one of two ways. The first is that it's always the longest side of a right triangle. And that's really easy to identify if the measurements of all three sides are given. But because things are not always drawn to scale, meaning that what you see is not really what you're getting, you can't really tell from the picture alone. So the second way to determine it is based on this right angle that I just circled. The hypotenuse is always opposite of that, or across the way from there. And the best way I've come up with to figure it out is the corner of this right angle always points to the hypotenuse, or side C. And that's really it. That's the hardest part about starting off the Pythagorean theorem. The legs A and B does not matter where you call them, so I'm going to call this one leg A, and I'm going to call this one leg B, but really it does not make any difference. It's all the same. Okay? Now, once you have your actual sides labeled and identified, there is a formula that was derived a long time ago by this said Pythagoras, known as the Pythagorean theorem. And what it says is that the length of leg A squared plus the length of leg B squared will always equal the length of the hypotenuse squared. Now, this is only true if it's a right triangle for two reasons. One, this only works for right triangles. That's the one reason. The second is you can only have a hypotenuse if you have a right triangle. There are no hypotenuse outside of that. So if I have length of A squared plus length of B squared equals length of hypotenuse squared, that's the formula. It just doesn't make a lot of sense to leave it like that because you don't want to write that out every single time. Like, it's obnoxious. So instead, just write it as A squared plus B squared equals, and you've probably heard this before, C squared. So let's just identify how we do this for these next three examples. On your notes, you may notice that there are no numbers or variables on any of the images. These are the numbers and variables to go with that. So for example 1, step 1, identify the hypotenuse. Right angle is here, it points to that side, that makes that the hypotenuse, otherwise known as side C. The other two could be A or B interchangeably, so I can call that A or B. I could go the other way around, doesn't matter. But I'm going to write out the whole formula, A squared plus B squared equals C squared. And from there, just basically fill in the formula from what I see. A, I just said is 3. B, I said is 4. And C is X. And I'm going to stop for a second and be very clear about something. It is really important to understand that it doesn't matter which one A or B is, but C has to be the hypotenuse. That's very important because if you don't do that correctly, nothing else matters. So 3 squared is 9, 4 squared is 16, and obviously we don't know what x is. That's the unknown length, so that's x squared. 9 plus 16 are on the same side. I can just add those. That's 25. And then at this point, you may or may not be familiar with how to solve. But remember, when you're solving for a variable, your goal is to get the variable alone. Right now, x is being squared. And the only way to get something alone is to remove or do the opposite of whatever operation is occurring there. For example, addition, the opposite is subtraction. And vice versa, subtraction's opposite is addition. Multiplication opposite is division. Division's opposite is multiplication. So the opposite of an exponent is known as a root. So squaring something requires the square root to cancel it out. That gets rid of the square. And you may or may not already know this, but the square root of 25 is just 5. If you're stuck on that idea, you can always come to me on an individual level and I will talk to you about that, or leave a comment or a question below. All right, so that's when you're trying to solve for what's called the hypotenuse. Sometimes you'll see something like example number 2, where the hypotenuse is already identified or measured. So side C is just 13. That leaves 12 and x as the A or the B, and it doesn't really matter which one. I tend to call the variable A, and the other one B. It just works better for me, but that's just me. So I'm going to go A squared plus B squared equals C squared. A is x, B is 12, and C is 13. 12 squared is just 144. 13 squared is 169. Now, where this is different from the previous problem is that obviously I'm looking for a leg. Well, when that happens, you may notice that your variable is on the same side as one of the numbers. So to solve this, what we have to do is subtract the 144 to make that x squared get alone. The catch is, anything you do to one side, you have to do to the other. We have to balance it. And so 144 subtracted from 169 is 25. At this point, you actually have the exact same problem as we did on previous one, example 1, where it was x squared equals 25. We already solved that by taking the square root of both sides, and that told us that x equals 5. This is a coincidence. This doesn't happen every time, so don't get too caught up in that idea. All right, so finally, those are really the two basic fundamental ideas of Pythagorean theorem. Either you're trying to find a hypotenuse or you're trying to find a leg. Really comes down to one of those two possibilities. There are other things you can do with it, but for now, that's all we're looking at. The third example is just more about what happens if it doesn't come out to be such a clean answer. So let's start this off. I can see that the right angle points to x, so that makes this the hypotenuse, part C. And I'm just going to call this A and B. So I'm going to have 6 squared plus 7 squared equals C squared. 6 squared is 36. 7 squared is 49. And since they're on the same side, this is very similar to example 1. I'm just going to add those two, which comes out to be 85. Now, the reason why this is so different is because if you go ahead and take the square root of both sides, and I've been calling this C, you can leave it a C or you can call it X if you prefer, but you'll find that the square root of 85 is not a clear-cut answer. It comes out to, so I calculated out here, 9.219544457 equals C. Now, that's not a very good answer. What you're going to find is that as we get into the higher levels of this, I'm going to show you how to what's called reduce or simplify a root. I'm not dealing with that right now. There are two possibilities here. The first is if the square root of 85 comes out to be what's called an irrational number, meaning a decimal that never ends and never repeats. That, by the way, is not the whole decimal. There's more and it goes on forever. Then you can either leave it in the square root format, which I tend to prefer, or the questions like your assignment today may say put it into decimal format with the 10th place. So we're going to round to the 10th place, which is the very first decimal. We're going to look to the decimal number to the right of it, and if that number is 4 or below, nothing changes, so that 2 would stay the same. If that number is 5 or above, that 2 would round up to the next decimal. In this case, it's just going to stay the same, 9.2. So at that point, I'm going to set that approximately equal. Sorry about that. Set that approximately equal to x, and that's going to be it. All right. So that in a nutshell is your Pythagorean theorem, what you need to be able to do by the end of this set of notes for this. First assignment will be pretty much just straightforward, these kind of problems. Worst case scenario, you'll see something like example 3 where you've got to chug it into a calculator. If you ever get stuck on anything, feel free to message me, email me, chat me on Teams, whatever it is that you need. And I will catch you later. Have a good day.